Question number 6. Mr. and Mrs. Ahmed with their two children and Mr. and Mrs. Barker with their three children are visiting an activity center together. They will divide into groups for some of the activities. In how many ways can the 9 people be divided into a group of 6 and a group of 3? When you have a question like this and you have the total number of given, total number is 11 and 9. 9 people is given as a total number. You have to divide them in a group of 6 and group of 3. So first you do is from the total of 9, you select 6. So that's 9C6. Once you have selected 6 from the 9, there are only 3 remaining. And from those 3, you will be selecting 3. So it's 9C6 times 3C3. That's how you do it. So from the total, you select the first number of group, the highest one. And then from the remaining, you select the second one. And that's going to give you 84 as the answer. That's part A done. Part B, 5 of the people are selected at random for a particular activity. Find the probability that, now this is, we are working on the probability, that this group of 5 people contains all 3 of the Barker children. So if Mr. Barker and Mrs. Barker have 3 children, so that's 3C3, I'm selecting all of them, 3. And from the remaining 9 people, now 9 minus 3, that's 6 from the remaining 6 people, that is, I have to select, I am selecting total 5. So I've selected 3. So from the 6, I am selecting 2 because I've already selected 3 and now I have to select 2 more in order to have the total 5 people. And those 2 are going to be selected from the remaining 6 that I have. So 3C3, children of Mr. and Mrs. Barker, and 6C2 from the remaining 6 people, the remaining 2 that I require in order to make them total of 5. So that's going to give me 3C3 is 1, 6C2 is 15, so that's just 15. And since I have to find the probability, so this is going to be 3C3 times 6C2. That's the option that I need, my requirement upon the total. This is my R, my requirement upon the total probability that I have, which is 9 people, and out of 9, I'm just selecting 5. So that's going to give me 15 over 9C5, that's 126, which is 0.119. That's the answer, 0.119. That's part B. Part C. Yeah, we have part C. So part C is all 9 people stand in a line. Find the number of different arrangements in which Mr. Emmett is not standing next to Mr. Barker. So let's say Mr. Barker and Mr. Emmett are standing next to each other. They are standing next to each other. So this is Mr. Emmett and this is Mr. Barker. So we make them as one block. So that's 1. Now, how many people do we have? We have 9. So these are 2 people. We have 7 more blocks. That's going to keep on going till we have the 7th block, right? And this is 1, 2, this is 3, this is 4, that's going to be 5. This is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is the total number of 9 people we have. But we are treating this Mr. Emmett and Mr. Barker as one block. So that's 1 because they always have to be together. And then we have 2, 3, 4, 5, 6, 7, and 8 remaining. 8 blocks remaining. So now Mr. Emmett and Mr. Barker can change positions. So that's just going to be 2 multiplied by, now they can change positions, and these all 8 blocks that I have over here, 1, 2, 3, 4, 5, 6, 7, 8, they can also change positions. So that's going to be 8 factorial, or 2 factorial times 8 factorial. And that gives me 8 factorial times 2 factorial. That would be whatever it is. That's 2 factorial. Let me just use a calculator. 2 factorial times 8 factorial. That gives me 80640. 80640. Okay. Now the total possible arrangements that I have without any restrictions, that's for the 9 people. And that's just going to be 9 factorial since all of them are different. They're people. So I cannot have common people. So it's not going to be divided by anything. No person is going to repeat. It's not letters or numbers. So that's 9 factorial minus that they are together. So total number of arrangements 9 factorial that minus that they are together is going to give me that Mr. Ahmed and Mr. Barker are not together. So 9 factorial. 9 factorial is 3, 6, 2, 8, 8, 0 minus, and we got this as 8, 0, 6, 5, 6, 4, 0. So we subtract this, we get 8, 0, 6, 4, 0. So we get the answer as 282,240 should be the answer, that they are not together. The total minus that they are together is going to give us that they are not together. That's part C done. Now part D. Find the number of different arrangements in which there is exactly one person between Mr. Ahmed and Mr. Barker. So now let's suppose Mr. Ahmed is over here. There's one person unknown over here, and then we have Mr. Barker over here. So there's always supposed to be one person over between the two. But it doesn't say where Mr. Barker and where Mr. Ahmed are supposed to be. So we can have Mr. Ahmed, then we can have the person, then Mr. Barker. Or we can have Mr. Barker, then that person, and then Mr. Ahmed. Still the person is between the two. So that means still Mr. Ahmed and Mr. Barker can change their positions. So that's still 2 factorial. And then we have, so now since all the three have to be together, since there always has to be a person between the two. So that means this 3 forms one block. So we have this as one block now. Since we had 9 people, so how many people are remaining now? How many persons do we have remaining? 9 minus 3, that's 6. So that's 1, 2, 3, 4, 5, 6 people remaining. And remember, this is one block, so that's 2, 3, 4, 5, 6, and 7 blocks. So we have 7 blocks. Now these 7 blocks can change their positions. So that's 7 factorial. And that's 7 factorial. So that's 2 factorial over here, where they can change positions. And that's 7 factorial, where this block number 1 can come. So block number 1 can come in the first place, block number 1 can come in the second place, third place, fourth place, fifth place, sixth place, seventh place. So that's just going to be into 7. And 7 factorial for the remaining number of people who can change their positions within the each block. So that's 2 factorial times 7 factorial times 7, and that's going to give you 70,560. And that is question number, last one. This was question number 6, part D done.